Hi everybody, my name is Soria Delva and I do climate change research at the Phycology Research Group in Ghent. So global climate change is severely impacting our natural environment, especially our oceans are having some tremendous changes due to an enhanced greenhouse effect. Examples of these changes include ocean warming, melting of polar ice caps, increases in extreme events and ocean acidification. As marine biologists, however, we're mainly interested in how all these changes will affect our marine life. So, how will all these organisms cope with our fast-changing climate? Unfortunately, here in Europe, we don't have all these tropical ecosystems, but what we do have, and we have lots of it, is seaweed. I feel like seaweed has been for long quite an underappreciated group, although they're very important for our coastlines. For example, they can be quite seen as our natural coast guard, since they're protecting our coastlines against erosion and also providing food and habitat for a wide range of species. Therefore, it's going to be extremely important for us that we can predict how all these ecosystems are going to respond to the predicted changes in our climate. And to already solve a very small part of this puzzle, I'm focusing in my research on one seaweed species. This is Dictyota dichotoma. It's a brown seaweed that occurs all the way throughout Europe and is very important in the structuring of benthic communities. So the whole idea of my PhD is to predict how this species will respond to climate change. The first step we do to investigate this is to find a relationship between some fitness components such as survival, growth, reproduction, and the environmental variables that will drive its distribution. In this case, we decided to focus on temperature, since ocean warming has already been shown to greatly impact seaweed ecosystems. So once we know this relationship between fitness and temperature, we can use this information to predict how this species is going to behave under different scenarios of climate change. However, if we do it like this, we make some assumptions that are not necessarily true. And one of the most important ones is that we don't take into account local adaptation. This means that we assume here that all the populations are having the exact same thermal thresholds, so that we can also describe them with exactly the same relationship. However, previous research has already shown that local adaptation does exist in the marine realm and is actually quite common. So with this information in our mind, we decided to rephrase our goal a bit. And instead of considering Dictyota as one unit, one species, we now want to know how different populations of this species will respond to climate change. So here what we will do is we just do the same thing, but instead we will describe this relationship for each population separately in the hope that we can now make some more accurate predictions of how this species is going to behave under climate change. So this is exactly what we're doing right now. So I'm focusing on 6 populations, which you can see here on this thermal map. So they range from Bergen in the north up to Sahara in the south, and they're chosen in this way that they kind of span the whole distribution of Dictyota in Europe. So over the course of the past summer, we already sampled and tested 3 of these populations. They're the ones in Finvara in Ireland, Goes in the Netherlands, and Noirmoutier in France. And I'm going to show you these preliminary results right now. So for each population, we measured the relative growth rates at different levels of temperature, and we used this to construct these thermal response curves. So as you can see, there's already slight differences here. For example, the population of Noirmoutier is shifted a bit more towards the right, so towards higher temperatures. And this also becomes more clear once we plot the optimum temperature of growth on there. So as you can see, there's already a difference of 1 whole degree between the optimum temperature in Goes compared to the one in Noirmoutier. The same pattern is observed once we have a look at the thermal performance ranges. So what you see here is the range of temperatures over which the species, or each population separately, grows well. So this is indicated by the red circles. The white circles again show the thermal optimum. And we kind of see the same pattern here, with the population in Goes growing well at much lower, not much, slightly lower temperatures than the one in Noirmoutier. So at the moment, we're still analyzing these data further. So we were now looking a bit more at the significance and the ecological relevance of these differences. So our next step will now be to link this up with the thermal patterns we observe at these locations to make the predictions of how they're going to behave and which populations will be more vulnerable to climate change. Next summer, we will sample and test this for the 3 other populations. So I hope I can just stand here next year and tell you a bit more about these data and these results. Thanks a lot.